Hello everybody, welcome to RH School. Today we're going to try out a worked example for solving for unknown angles, but this one is a test type question. So let's dive straight in. So in this example, we are given a quadrilateral JKLM and this is a rhombus. So JKLM is a rhombus and we are required to calculate the sizes of angle JML, which is over here, and angle M2, which is just this spot, just this angle, and we are also required to calculate angle K1, which is on this angle. So if we look at this problem, the fact that we are told that JKLM is a rhombus, it means that we'll probably have to use its properties, right? And what does this mean? So this question involves a knowledge of the properties of quadrilaterals, and in this case, this quadrilateral is a rhombus. We get other types of special quadrilaterals, which are squares, rectangles, and parallelograms. So if we just look at this diagram or this rhombus, what information are we given? Do you see that JM is parallel to KL? And we know this because of the single arrows that are on these lines. This tells us that they are parallel to each other. We are also told that LM is parallel to KJ, and in this case we know this because there are double arrows on each of these lines. And that is actually a property of a rhombus. The opposite sides of a rhombus are parallel. We are given an angle over here where angle MLK or angle L is 102 degrees. And we are also given angle M1, M2, K1, and K2. So with our given information, what do you notice about the parallel lines? If we first look at JM and KL, did you see that we can have co-interior angles? And this means that we have a U lying on its side, and our co-interior angles is between the parallel lines JM and KL in this case. So what does it mean when we have co-interior angles? When we have co-interior angles, the sum of the co-interior angles are supplementary. And what does that mean? It means they are equal to 180 degrees. So our co-interior angles is the whole angle of JML, which is M1 and M2, and the angle 102 degrees. And if we add them up, since they're co-interior angles, it should equal to 180 degrees. Our reason is co-interior angles, and we know this because we know that JM is parallel to KL. It is given. We should always say why we know. We should always give a reason of how we know what type of angles on parallel line it is, whether it is corresponding, alternate, or co-interior. We should always say how we know this, and it's because of the fact that JM is parallel to KL. You should always state which two lines are parallel to which. That tells us whether it's co-interior, alternate, or corresponding. So now that we know this, this makes a linear equation. So to solve for angle JML, we take 102 to the other side, and that will be 180 degrees minus 102 degrees, and therefore JML is equals to 78 degrees. So there we go. We already calculated the size JML. Now we're left with M2 and K1. So now if we look at our rhombus and we use the information that's given, in this case now, what else does the parallel lines tell you? If I look at ML and JK, yes, they are parallel, but what type of angle can you identify? What type of angle can you see? Did you also see did you also see that that there is a Z lying face down? Did you also see that, guys? And if we have alternate angles, and we know that's why, because ML is parallel to JK, indicated by these two arrows. So if we have alternate angles, what does it tell us about angle M2 and angle K1? They are surely equal, right? And that is fantastic now that we know that, but do we know what is angle M2? We don't. And we also don't know what's angle K1. So in this case, we cannot solve for K1 until we solve for M2. Yes, there are other ways to solve this problem, but if we looking at solving for M2 first, then we cannot solve for K1. Um, so what else can we then use? We can use the fact that JKLM is a rhombus, and therefore we can use its properties to help us solve for the rest of the unknown angles, M2 and K1. So if you use the properties of a rhombus, what do you know about, let us just explore the properties. What do we know about the opposite angles of a rhombus? They are equal. So 102 degrees, angle L, will equal to angle J, and therefore angle J will be 102 degrees. Likewise, we use the fact that the opposite angles of a rhombus are equal, then the whole of K, angle K, will equal to the angle JML, or the whole of angle M, which is M1 and M2. The other property of a rhombus is that the opposite sides are parallel to each other. And here we are given this information. JM rather, is parallel to KL, and LM is parallel to KK. The other property is that the diagonals bisect the opposite angles. And what does that mean? When we say bisect, we mean that it cuts the angle in half. It cuts the angle into two equal sizes. And what is our diagonal in this case? It is MK. And do you see that it cuts the whole of angle JML, or angle M, into two, which is now given as M1 and M2. So if it bisects, if this diagonal MK bisects angle M, what does this mean? It means that it cuts the whole of angle M into two equal parts, which means M1 is equals to M2. Likewise, this diagonal bisects angle K, and therefore angle K1 and K2 will be equal. So now that we know that, would it be correct for me to say M1 is equals to M2? Yes, and we will use the reasons from the properties of a rhombus. So there we have it, all the properties of a rhombus. Opposite sides are parallel, we just discussed that. All sides are equal, very important one. JK is equal to KL, which is equals to LM, which is equals to MJ. And the opposite angles are equal. Diagonals bisect each other at right angles. Now, just a quick explanation of this property. This means that now we have one diagonal, which is MK, but we can also have another diagonal over here. Oops, sorry, that's a little wonky. But we have diagonal MK and JL. So when diagonals bisect each other at right angles, this means that it will cut each other at 90 degrees. So all these angles that I am making will be equal to 90 degrees. And that's basically what it means. But for our purposes, we want to calculate M2. And so now that we know M1 is equals to M2 because opposite because diagonals bisect opposite angles, the one highlighted in yellow, what reason will we give? Exactly that, the property of the rhombus. We can simply say diagonal bisect interior angle, and thus is the symbol for angle of a rhombus. You can write it out in a full sentence that is also perfectly correct. This is just a shorter way. So now that we know that, how do we go about solving for M1 and M2? We can work with M1 and M2 just as it is, but I find it easier if we can call it a variable, something like x. So if I let m2 is equals to x, surely m1 is equals to x, right? Because m1 is equals to m2. So if I say let m1 equals to m2 be x, then what does this mean? It means that the whole of angle JML is equals to x plus x. And since they both have the same variable, we simply add the coefficients. Now what is special is that the coefficient of these two variables are 1, and although it's not written here, there's whenever you just see a single variable, the coefficient or the constant in front of it will always be a 1, because 1 times anything will always be the thing itself. 1 times x is x, 1 times y is y. So we'll just add the coefficients. So JML is equals to 2x. And to isolate x, or to get x alone, or to solve for x, we will divide by the constant in front of the variable, and our variable is x. So we will say divided by 2 on both sides. Well, just a second. Do we know what's JML? 100% we do. We calculated it earlier. JML is equal to 78 degrees. So let us substitute that in. And so if you want to isolate x, we divide both sides by 2, and that gives us 39 degrees. So x is equals to 39 degrees. But were we looking to calculate x? No. We want to find out what is m2. But since we called m2 to be x, m2 is equals to 39 degrees. Fantastic. So now we just have to calculate one more unknown, which is k1. And remember we discussed earlier the fact that ML is parallel to JK, therefore the alternate angles are equal. So that means M2 is equals to K1. So now is our time to use it. So there I highlighted it in orange. A tip for you everybody is that when you're working with geometry problems, always use color. It really helps to see certain information much more clearer. So now that we know that M2 is equals to K1 because of alternate angles, let's write it down. The M2 is equals to K1, and our reason is alternate angles. I wrote it in shorthand, and we know this because ML is parallel to JK. Please be sure of which parallel lines you're working with. Remember that M2 and K1 is related to the parallel lines ML and JK. It would be wrong to say that it's because JM is parallel to KL. No, because these alternate angles does not lie between the parallel lines of ML and JK in the transversal. So you must be sure that you're working with the correct set of parallel lines. And now that we know that M2 is equals to 39 degrees, and since angle M2 and angle K1 are equal, K1 is equals to 39 degrees. And there you have it, everybody. That is a typical test type question, and I hope it helped. Thank you so much. Please like and subscribe.